Okay, for this video, this one's going to be really short. This one is just about moments, and uh, this one's going to come up again in a little while when we do trusses. So I'm doing this one a little bit separate. I'll come back and talk about levers in more detail, but basically there's three types of levers. If you have a fulcrum or a pivot point, and then you have a resistance force, and then the force that you're actually applying, then you've got a lever. So there's three types of levers: first class lever, second class lever, and a third class lever. And I'll go into more details about each of these in the next video. But what I want to talk about in this one is something called a moment. And if you know what torque is, moment is kind of another word for torque. It's the turning effect of a force about a point. In this case, it's our little triangle here. It's our fulcrum. And it's equal to the magnitude of the force times the perpendicular distance from the point. The way we calculate it is our moment is equal to the distance times the force. And if you remember from our last video, work, when we talk about work in the scientific or in the physics sense, work is force times distance. So when we calculate moments, we're really just calculating the amount of work done. But this is specific to things that are, excuse me, like a lever or are turning. So this is also the definition of torque: a force that produces or tends to produce rotation or torsion. So when we calculate a truss, there will be a pivot point, which is basically where our truss, or it's another term for like the support structure of a roof, is going to be secured to the wall. And then there's going to be the weight of the roof pushing down on it, and so we're going to get some torque or a moment, and we're going to have to calculate the moments. So this is how we calculate it. Our effort force is 5.5 inches from our fulcrum, and the amount of the force is 15 pounds. So we can calculate the moment by taking the distance and multiplying it times the force. So our effort force is 5.5 inches times, effort moment, not effort force, 5.5 inches times 15 pounds, which gives us a torque of 82.5 inch-pounds. This is how we calculate a moment, and we'll be using this again a lot later.